You think the AI race is about chips? Wrong. Before an AI model can answer a single question, someone has to feed it electricity. And that electricity does not come from a keynote, a venture capital pitch, or a shiny GPU box. It comes from power plants, transmission lines, substations, transformers, cooling systems, water rights, land permits, and utility contracts. That is the part most people never see. AI looks like software on the screen, but behind the screen, it is becoming one of the biggest industrial infrastructure races on Earth. The uncomfortable truth is this: the next bottleneck in AI may not be the smartest model. It may be a transformer that takes years to deliver, a grid connection that cannot be approved fast enough, or a power bill so large that even the richest technology companies have to rethink where they build. This is not just a story about artificial intelligence. It is a story about electricity, land, water, hardware, and the companies quietly making money before the model even starts running. For the last 2 years, the public story of AI has been simple: more chips, more GPUs, bigger models, more data, more compute. And that story is not wrong. Without advanced chips, modern AI would not exist, but it is incomplete because chips do not run in the air. They sit inside servers. Servers sit inside data centers. Data centers sit on land. That land needs power. That power needs transmission. Transmission needs substations. Substations need transformers. Transformers need copper, steel, insulation, cooling oil, factory capacity, skilled workers, and years of planning. So when people say AI is scaling fast, they usually mean the software is scaling fast. But the physical world does not scale like software. You can update a model overnight. You cannot build a power grid overnight. According to the International Energy Agency, global electricity consumption from data centers could more than double by 2030, reaching around 945 terawatt hours. That is slightly more electricity than Japan uses today. Think about that for a second. A single digital industry is growing into the power demand of a major industrial nation. Training large models is expensive, but inference may become even more important. Every time someone asks a chatbot a question, generates an image, searches with AI, writes code with an assistant, or runs an AI agent in the background, electricity moves through a physical system. The user sees a clean answer. The grid sees load. And that load is starting to reshape the business of energy. A data center is not just a building full of servers. It is an industrial machine. It needs land. It needs fiber. It needs backup power. It needs cooling. It needs water or advanced cooling systems. It needs switchgear. It needs transformers. It needs long-term electricity contracts. And most importantly, it needs permission to connect to the grid. That last part is becoming a problem, because the grid was not built for thousands of AI facilities arriving at once. It was built slowly, over decades, around cities, factories, homes, and old patterns of demand. Now, a single AI data center campus can appear on a planning map and ask for hundreds of megawatts. Some proposed campuses are moving toward gigawatt scale. That is not a normal commercial building. That is a new industrial load. And when that load arrives, it does not just ask for electricity. It asks the entire system to change. This is the strange new reality of AI. The most advanced software in the world may be delayed by some of the oldest hardware in the electrical system. Transformers are a perfect example. They are not glamorous. They do not appear in AI demos. No CEO walks on stage and says, "Look at our transformer procurement strategy." But without them, electricity cannot move at the right voltage through the system. And as AI data centers expand, demand for grid equipment is rising faster than supply. Some transformer lead times have reached more than 160 weeks. So while AI companies talk about moving fast, the grid is forcing them to wait. AI wants software speed, but it depends on infrastructure speed. That contradiction is creating winners. Most people are not watching. Power companies, transformer makers, switchgear suppliers, cooling system providers, electrical contractors, landowners near strong grid connections, natural gas plants, nuclear developers, battery storage companies, water treatment providers, data center landlords, and engineering firms that know how to connect massive loads to fragile grids. The AI gold rush is not only inside the model, it is outside the model. It is in the boring equipment that makes the model possible. But there is another side to the story. Someone has to pay. When a data center arrives, the local power system often needs upgrades. New lines, new substations, new transformers, new generation, more reserve capacity, better cooling infrastructure. These projects are expensive, and the political question is simple. Should the data center pay for the upgrades it needs, or should the cost be spread across households and businesses through electricity bills? This is where AI stops feeling like a futuristic technology story. It becomes a monthly bill story. A factory owner may not use AI. A family may not care about large language models. A small business may never train a neural network. But if grid costs rise, they can still feel the impact. That is the hidden tension of AI infrastructure. The benefits may go to tech companies, cloud platforms, and AI users around the world. But the costs can land locally. So the next AI race may not be won only by the company with the best model. It may be won by the company with the best power strategy. The value is not only in the product, the value is in the system around the product. An AI company does not scale only because it owns chips. It scales when it controls compute, power, cooling, land, grid access, and operating cost. Because intelligence is not free. It has a power bill. If electricity does not arrive at the right place, at the right voltage, at the right time, the smartest model in the world is just code waiting in the dark. AI does not begin with intelligence. It begins with electricity. This is factory logic.